All right, so, wrong page. There we go. So we're going to look at 2.3 multi-step equations, and this is going to be a two-day lesson. So we're going to look at solving multi-step equations, and in particularly today, we're going to look at two-step equations. So eventually we're going to get to where we're going to do multi-steps, but today we're going to look at two-step equations. So again, our whole goal for this whole lesson, as a whole, both lessons combined, we want to be able to solve equations involving more than one operation. And then we want to solve equations involving consecutive integers. We're not necessarily going to talk about this one. So this one we kind of draw an X on. We're definitely going to be looking at solving equations with more than one operation. All right, and again, this 2.3 multi-step equations, we're going to be looking at more of two-step today. All right, not the dance, but solving equations. So you might want to write this down. This is something to think about when working with two-step equations in a certain form, and you'll see the forms we're going to talk about today. We want to solve working backwards. Okay. Normally, order of operations, we do multiplication, division, then addition, subtraction. But when we're solving these particular two-step equations, we want to get rid of addition and subtraction first, and then get rid of multiplication and division. So how I think about it, get rid of whatever's not with the variable, move that to the other side of the equal sign, then move whatever's attached to the variable. All right, so again, you might want to write these down. Get rid of addition and subtraction, then get rid of multiplication, division. So let's use what we just talked about to try to solve these problems. So the first problem we have is 2x plus 11 equals 3. So we're used to seeing like x plus 11 equals 3 or 2x equals 3. We're used to seeing those. Well, now we're going to build on it. So if we follow our steps, we want to get rid of the addition subtraction first. So if we see there's a plus 11, so remember the inverse operation of addition is subtraction. We're going to subtract 11 because the 11 is not attached to the x. And if I subtract 11 on the left, I have to subtract 11 on the right. Those 11s go away, leaving us with 2x equals, well, 3 minus 11 is going to give us a negative 8. I am not done. My variable is not by itself. Well, 2 is being multiplied by the variable, so to undo multiplication, we divide. So we're going to divide by 2 on the left side, and we're going to divide by 2 on the right side, leaving us with x equals 8 divided by 2 is 4. A negative divided by a positive is a negative. So then x equals negative 4. Now we can substitute, we can see if we did this correctly. Just like we did with one-step equations, we can see if we solve this correctly. So let's plug negative 4 back in for x. All right, so let's plug this back in. Let's see what we got. So we got 2 times negative 4 plus 11. Well, 2 times negative 4 is negative 8 plus 11. Negative 8 plus 11 is going to be 3. I got 3. I was supposed to end up with 3. Boom. That's how I can check to see if my answer is correct. Remember, so you can always check to see if your answer is correct just by simply plugging the number back into the equation in place of the variable. All right, so let's look at another one. K divided by 12 plus 9 equals negative 2. Well, remember, let's work backwards. So let's get rid of the addition first. Well, we're adding 9, so we're going to subtract 9. If I subtract 9 from the left, I got to subtract 9 from the right. The 9s go away on the left, leaving me with k over 12 equals negative 2 minus 9 is negative 11. Now let's see here. I have k divided by 12 equals negative 11. K is not by itself, so I need to move that 12. Well, if we remember, to undo division, I have to multiply. So I'm going to multiply by the denominator, multiply by 12. Those go away. If I multiply by 12 on the left, I have to multiply by 12 on the right, giving me k equals negative 11 times 12. That is going to be 132. And a negative times a positive is a negative. So k equals negative 132 Boom. And again, you can plug that back in for K and see if you did it correctly. So this is how we solve two-step equations. Think to work backwards. Look to get rid of your addition subtraction first, then get rid of your multiplication division last. And again, that theory, that concept works with when we see problems like these two. All right, and we'll talk about what happens if we don't run into a problem like these two on our next video. So what I would like you to do now is I got to move things out of the way so that you can see the problems. Got things in the way. I'd like you to solve these two problems on your own. The one on the right is a little tricky. I put that variable on the right side, but you still use the same concept. So if you could, please pause the video now and try these on your own. All right, so when you solve these two, the one on the left, you should have gotten y equals negative 12. And the one on the right, you should have gotten 39 equals y. If you would have had y equals 39, again, that works as well. Again, if this is something where you're like, I did not get those answers, I'm confused, put a star by it so that when we check with each other after the video, we can kind of talk about maybe these problems. All right? All right, so let's do another thing. All right, so what if we run into problems like these? All right, look at the one on the left. 3 minus h equals negative 11. This one may look like a one-step equation, but it is actually a two-step equation. So remember, the whole goal is we want to get rid of addition, subtraction first. We want to get rid of whatever is not necessarily attached to the variable first. If we look, this 3 is not really attached to the h. It's not being multiplied or divided by h. So we want to move the 3 first. Well, how can I get rid of the 3 on the left side? If you look, it looks like there's a minus, so you're going to think, oh, I think I got to add. Well, if I add 3, then it gives me 3 plus 3, which is 6. 6 isn't going to get rid of it. So what is the opposite of a positive 3? It would be a negative. Oh, that's a negative 6. My fault. The opposite of a positive 3 is a negative 3. So we're going to subtract 3 because 3 minus 3 is going to be 0. Makes those go away. Subtract 3 from the right side. If we take a look, this leaves us with this minus h equals negative 3 minus 3, or negative 11 minus 3 is negative 14. We look, the h is not by itself. It looks like it's by itself, but there's a minus sign. So really, there's actually a minus 1 there. Okay, so it's negative 1 times h. Well, if it's negative 1 times h, that means I need to divide by a negative 1. Divide by a negative 1. These negative 1s go away, leaving me with h equals negative divided by negative is a positive. 14 divided by 1 is 14. So h equals positive 14. So one cool little trick, if you see a minus sign in front of the variable, just change the sign of the other side. So let's look at it here. I'm going to go back to this one again real quick. Again, like I said, it looked like it was one step, but we actually did 2 steps here. We subtracted 3, then we divided by negative 1. So that's why it is a 2-step equation. Let's look at this next one. Negative y plus 17 equals 11. Well, let's see here. What is not attached to the y? Well, the 17 is because it's being added. So now I want to get rid of the 17, so I'm going to subtract 17. If I subtract 17 on the left, I have to subtract 17 on the right. So then we're left with negative y equals 11 minus 17 is negative 6. Again, this y is not by itself. There's that minus sign in front of it. So we get divide by a minus, divide by a minus. The negatives go away, leaving us y equals 6. So even if you don't see a number in front of a variable, but there's a minus sign, you still have to get rid of that negative sign or minus sign because the minus says our variable is not by itself yet. All right, so I want you to try these on your own. A little tricky. If you have to, look back at what the examples we just did. Try these on your own. See if you can, how you do. So again, pause the video and try these on your own. So pause it now. All right, so the one on the left, you should have gotten x equals -7. And the one on the right, you should have gotten -7 equals w. So hey, pretty cool. We ended up with the same answer for different problems. So that's kind of cool. But again, the one on the right, if you would have had w equals -7, that would have worked okay as well for here. So again, if these are problems that are still screwing you up a little bit, you're still really like, oh, confused on that one. Put a star next to it, because here in just a little bit, we're going to get together and we're going to talk about, what we learned, see if there's anything that's still confusing, and all that nature. So again, this is it. Make sure you have all your notes written down. Make sure you have these examples. And if you have any questions, make sure you put a little star next to it or something, or jot down a little question that you have, so that when we do come together, you can be like, hey, Mr. Harris, I do have a question on this one.